Hello everyone. This video sessions will be for your IAT exam, which is your IISER aptitude test. This exam is for admission into IISERs for your graduate or undergraduate or integrated MSc courses, or undergraduate courses. Okay, so you will be solving the previous year questions of IAT, which will be held in June, of course. And I hope you have a lot of time. Your board exams will be over after that. I think you have 2 months to prepare for this exam. So here I'll be providing previous year questions and their solutions. So you please try to solve them in meantime. Okay, and that will really help you. Okay. So we'll start the video with question number one. Okay, this is a mixed previous year question type videos. Okay, so you write down a point charge. A point charge Q is placed. This will also help in preparation for NEST, which is a NISER entrance screening test for admission into NISER Bhubaneswar. Okay, which is also another very good research center where you can do your integrated MSc. Okay, a point charge Q is placed at the center of a center of a conducting grounded cubic cell of side A. Okay. What is the electrostatic potential? Electrostatic potential? What is the electrostatic potential? V at a distance. Is the electrostatic potential V at a distance? Vx greater than root 3 by 2a. Okay. From the point charge. From the point charge along a along a body diagonal of the cube. Along a body diagonal of the cube. Okay, along a body diagonal of the cube. Okay, so the diagram is like this. This is a perpendicular. So this is a point where you have to find the electrostatic potential along a body diagonal. Okay, this is the side of the cube is A. All the sides are A. So the question is point charge is placed at the center of a. So this is a point charge is placed at the center. Okay, okay. Here is center and of a conducting grounded cubic cell. So it is grounded also of side A. What is the electrostatic potential V at a distance x, which is greater than root 3 by 2a from the point charge. Okay, point charge is Q at the center of the cube along a body diagonal of the cube. Body diagonal, that means like this. Okay, please try this question. Question is, what is the electrostatic potential V at a distance x greater than root 3 by 2? Okay, I will give you the options. Option A, V is equal to 0. Option B, V is equal to 1 by 4 pi epsilon naught Q by X. Option C, 1 by 4 pi epsilon naught. V is equal to 1 by 4 pi epsilon naught 4qx by 3a square. Option D, V is equal to 1 by 4 pi epsilon naught root 3 qx by 2x square. So qa by x. Okay. Voltage Q is placed at the center of a conducting grounded cubic cell of side A. What's the electric potential V at a distance x greater than root 3 by 2a from the point charge along a body diagonal of the cube? So see, what are the important terms that you should see from this question? So important terms you should notice is, say, conducting grounded cubic cell. Grounded, it's grounded like this. That means what? Grounded means okay. The potential is zero. Yeah. Conducting grounded cubic cell. Okay. So the charge at the center is Q. So what will be the charge on the faces? On the inner faces? On the inner faces, the charges will be minus Q. Okay. Remember that. Minus Q in the inner faces of the cube. So just write charge on inner faces like individually is equal to what of the cell is equal to minus Q. Okay. As the cell is grounded only, this minus Q will persist. Okay. Is it all right? And so your potential VQ plus potential V minus Q, the total potential will be what? It will be zero, right? The total potential VQ plus V minus Q will be 0. Simple, straight and simple, right? Yeah. Because see, the inner, this is on the inner face, right? Okay, for example, the Q is here. For it, the potential is what? At a distance x greater than root 3 by 2a, suppose. So V is equal to 1 by 4 pi epsilon naught because of plus Q. Okay, because of plus Q. Plus Q by root 3 by 2 into a. Okay, because of minus Q. As the minus Q charge is inside, so it will be 1 by 4 pi epsilon naught minus Q by root 3 by 2a. Okay, right? So that's it. So if you see the total potential here is V is equal to V plus Q plus V minus Q, that is 0. Okay, yeah, this is all right. Yeah, that's the answer. Answer is 0. Question number 2. You know, consider consider that in a fusion of in a fusion of a single uranium U-235, okay, atom, 200 megavolt mega electron volt energy is released. Assuming assuming all atoms of uranium assuming all atoms of uranium undergo fission undergo fission. Okay. Which of the following options which of the following options is the closest estimate is the closest estimate of the amount of uranium the amount of uranium required for a 20,000 units 20,000 units of TNT explosion. Okay, given also 1 unit of TNT is equal to 4.184 into 10 to the power 9 joule. Okay, it's given in the question. So try. What is the closest estimate of option? Which of the following options? Okay, options are 0.5 kg, option B 10 kg, option C 1 kg, option D 60 gram. So please try. Consider that in a fusion of single uranium atom, 200 megaelectron volt energy is released. Assuming all atoms of uranium undergo fission, which of the following options is the closest estimate of the amount of uranium required for the 20,000 units of TNT explosion? How to solve it? You have to use a bit of chemistry also here. Okay, first see. Consider in a fission of a single uranium, 200 megaelectron volt energy is released. Okay, so single uranium 200 megaelectron volt. Okay, so for example, there are n uranium atoms. Okay, suppose n uranium atoms. So it will be n into 200 megaelectron volt. Okay, and if you see, assuming all atoms of uranium undergo fusion, suppose n atoms. Okay, which of the following options the closest estimate of the amount of uranium required for 20,000 units of TNT explosion? So TNT is exploded in how much units? 20,000 units, and 20,000 unit of TNT is equal to your all the fusion of uranium, that is N into 200 megaelectron volt, right? Because all the atoms of uranium undergo fusion. So which is the closest approximate of amount of uranium required for 20,000 units, right? So 20,000 units of TNT, that will be equal to your N into 200 megaelectron volt of uranium, right? So that's the calculation. So 20,000 into TNT, 1 unit of TNT is this much. So just put it 4.814 into a 9 joule is equal to N into 200 into mega electron volt 10 to the 6 into electron volt 1.6 10 to the minus 19 joule. Okay, so joule cancelled out. Now if you do the calculations, it will be okay 200 and 20,000, that will give me 100. So N is equal to 100 into 4.184 into 10 to the power 9 divided by 10 to the power 6 into 1.6 into 10 to the power minus 19. Okay, so this is the calculation. Just have to do the calculation. So this is your 10 to the power 3. This goes up, becomes 10 to the power 19. Okay, and you just have to calculate this one. So if you calculate it, you will get it as 2.615 and 10 to the power 24. Okay, you will get this. Because if you see this 100 into 3, that is 10 to the 5. 10 to the 5 into 10 to the 19 is 10 to the 24. Okay. So this is your number of uranium. Right. We have to find out the estimate mass of uranium. So this is number of uranium. So what is the number of moles of uranium? We find the moles of uranium is if we divide it by 6.023, right? We will get the moles 6.023 into 10 to the power 23 atoms. If we divide it, we will get it as 4.34. After calculation, I'm writing. Okay. So if you see, what is the molar mass of uranium? That is 235. So molar mass of uranium is how much? 235 gram. 235 gram. So what will be the mass of uranium? This is the number of moles. 4.342 number of moles of uranium. Molar mass of one uranium is 235 gram. So what will be the whole mass? The mass of uranium will be how much? The molar mass into the number of moles, like number of moles into molar mass, right? So number of moles is 4.342 into 235 gram, right? So if you calculate it, you will get 1020 gram, which is approximately equal to 1 kilo. Okay, so the answer will be 1 kilo. Is it all right? Is it understandable? Okay, right. Let's write the next question. Question number 3. Question number 3. Particle moves. The particle moves with finite velocity, and acceleration. The velocity of the particle, the velocity of the particle is perpendicular to its perpendicular to its acceleration at any instant of time. At any instant of time. Which of the following which of the following statements about the particle statements about the particle, to the following statements about the particle is always true. Is always true. Okay. Option A, angular momentum is conserved. Option B, linear momentum is conserved. Option C, kinetic energy is conserved. Option D, acceleration is zero. Okay, please try. Particle moves with finite velocity and acceleration. Okay, the velocity of the particle is perpendicular to its acceleration at any instant of time. Which of the following statements about the particle is always true? Let's try this question. Particle moves with finite velocity and acceleration. The velocity of the particle is perpendicular to its acceleration at any instant of time. Which of the following statements about the particle is always true? Not class, very good. Okay. See, particle moves with finite velocity and acceleration. Velocity of the particle is perpendicular to its acceleration. Velocity is perpendicular to acceleration. Which of the following statement is true? Okay, velocity of the particle is perpendicular to the acceleration. That means if two vectors are perpendicular, can I say A dot B is equal to 0? So I can write it here. V dot A is equal to 0. Okay. Now what is the acceleration? Acceleration can be written as dv by dt, the rate of change of velocity, right? So v dot dv by dt is equal to 0. Okay. Okay. V dot dv by dt is equal to 0. Hmm. So I can multiply 2 on this side and other side, it will be same thing, is equal to 0. Right. So I can write it as v dot dv by dt plus dv by dt dot v, because dot product doesn't make, like, it can be commutative. A dot b is equal to b dot a, right? So v dot dv by dt plus dv by dt dot v, it's the same thing. V dot dv by dt, that is 2, right? Addition of these two is 2 v dv by dt is equal to 0. So can I write like this? D by dt of, can I write this thing as v dot v, isn't it? See, dv by dt into v plus v into dv by dt, right? So this is d by dt of v dot v, that is dv by dt of d by dt of v square is equal to 0, right? V square is equal to 0. So if I take the dt to that side, dv square is equal to 0, and if I take the integration, otherwise see, Derivative of v square 0. So derivative of anything, if it is 0, then this anything is a constant, right? Derivative of 4 is 0 because 4 is a constant. So derivative of v square is constant. That means v square is constant. V square is constant. So if v square is constant, the mass of the particle is constant. So I will multiply mass on both sides. Mass is constant. So constant in constant is again constant. And also I will multiply half. So half mv square is equal to constant. So if you see, half mv square is a what? Kinetic energy. So kinetic energy is equal to. So you have to prove it. You have to think a bit. Okay, otherwise it's not direct question. Kinetic energy is conserved. Okay, is it alright? Is it all right? Is it all right? Okay, this way you have to prove. You have to think a bit, analyze a bit, and then do it. Okay, next question, question number 4. Question number 4. Just a second. Okay, next question right now. Question number 4. Two spherical conductors. Two spherical conductors A and B. A and B of radii radii A and 2A contain contain minus q and 2q charges respectively. they come in contact they come in contact with they come in contact each other with each other due to electrostatic attraction and eventually move apart and eventually move apart. Okay, what will be the ratio what will be what will be the ratio of the of the final charges on A and B. Okay, the two spheres are here. This is your A minus Q. This is your 2A. This is your 2Q. Okay, yeah. Two spherical conductors A and B of radii A and 2A contain minus Q, 2Q charges respectively. They come in contact with each other due to electrostatic attraction and eventually move apart. What will be the ratio of the final charge on A and B? Let's try. The options are, yeah, options I will give you 1 by 4, 1 by 2, 1 and 1 by 8. Okay. See here two spherical conductors A and B. Okay, ready 1A and 2A minus Q 2Q respectively. They come in contact with each other. So they are coming in contact with each other. Right. Okay. And then due to electrostatic repulsion eventually move apart. Let's first write down all the data that is given to us. RA is equal to A, RB is equal to 2A. Right. And initial charges, we will write initial charges minus Q on A and 2Q on B. Okay. Yeah. So they will come in contact with each other. Okay. The come in contact, that's a very important term. Come in contact with each other. So what will happen when they come in contact? What will happen? Their potential will become same. VA will be equal to V. Okay. VA will become equal to V. Alright. Their potential will be same. So this is a what? If you see, this is a spherical capacitor. You can say. Okay. This is a spherical capacitor. It has charge. It has potential. So if you see this is a spherical capacitor concept. Spherical capacitor. Okay, what is the formula for it? C is equal to 4 pi epsilon naught. Okay, there is a charge inside and charge outside. So sorry, um, if you see, um, just a second. No, sorry, R inside R. Okay, there is this formula C 4 pi epsilon R in into R out divided by R out minus R in. Okay, R out by R in. Out. And here another formula is there, that is if R out is tends to infinity, what will happen? What will happen? I will just divide C 4 pi epsilon naught. I will divide R out on both numerator denominator. That will be 1 minus R in by R out. So R out tends to infinity. That means this term will become 0. So 4 pi epsilon naught R in. This is the capacitance. Okay, this is your capacitance. And if you see these two capacitors here, only Rin is there. A, this is 2A. So C1 by C2, if you see C1 by C2, that is R in 1, R in 2, that is A by 2A, that is 1 by 2, isn't it? 1 by 2. Now we know C is equal to what? Charge by potential. Here potential is both of them for potential same. Why? Because they come in contact, so potential is same. So charge is only varying. So C1 by C2 is equal to Q1 by Q2 is equal to 1 by 2. That is the question, right? What is the ratio of the final charges in the game? So is it all right? Okay, so that will be the answer. Okay, is it all right? That will be it for this class. Okay, we're solving more questions in the upcoming sessions. Okay, so please stay tuned to us. We're solving more questions. All right. Thank you very much.